we want to discuss about electric power and Joule heat energy equation when current is passing through the conductors. Now, electrical power, we know the symbol of it, P. Now, what is electric power? The utilized electrical energy, the utilized electrical energy in a time, the utilized electric energy in a time is called electric power. And we know the mathematical expression for the power, P is equal to work by time. But how we can write the work here? V into Q. What is a V? V is called as electric potential. What is a Q? Charge. How we can get this equation? From the definition of electric potential. What is the definition of electric potential? Work done on unit positive charge to shift against the field from infinite distance to a certain point is called electrical potential. What is the mathematical equation for electrical potential? V is equal to work by charge. V is equal to work by charge. So, work is equal to electric potential into charge. So, that is this. Work is equal to electrical potential into charge. Charge by time is called current. Charge by time is called current. That is why what is the mathematical expression for the electrical power? P is equal to V into I. What is the V? V is electric potential. What is I? Electric current. The product of electric potential and electric current is called electric power. Now, what is the unit for the electrical power? Power unit is always watt. What is the unit of electrical power? Watt, W. Okay. Now, this power is expressed by another three mathematical forms. The first mathematical form is P is equal to V into I. Another two mathematical forms also for electrical power. And what are the two another mathematical expressions for the power is? Now, first, we know the last class, get the equation for resistors connected in series and parallel. If resistors are connected in parallel, which is same? Voltage is same. Actual potential is same, but what is the unit of potential? Voltage. That's how we can say voltage also we can write. If the resistors are connected in parallel, voltage is same, means potential difference is same or voltage is same, then you write V as it is here, but instead of I, how we can write? Instead of I, we can write V by R. How we can get that from Ohm's law? From Ohm's law, V is equal to IR, I is equal to V by R. Here potential is same, that's why we can take like this. Means instead of I, we can take V by R. V into V, how much? V square by R. This is the another expression for the electrical power. When we use this equation, when the resistors are connected in parallel. Resistor means not only a resistor, you take another one also. Bulbs are connected in parallel, we use this formula. P is equal to V square by R. When we use this principle, when the resistors or conductors are connected in parallel. Okay. If the resistors are connected in series, the same equation? No, equation is different. Now let us see how we can get it. If the resistors are connected in series, When the resistors are connected in series, which is the same? Current is same. When the resistors are connected in series, current is same. That's why what we can write? P is equal to V into I. But in series, which is same? Current is same. That's why remove the V. Instead of V, you can write IR, Ohm's law. Instead of V, you can write IR. So I into I square R. Means when the resistors are connected in parallel, the electrical power is V square by R. When the resistors are connected in series, what is the equation for electrical power? I square R. Okay. Totally how many expressions we got for electrical power? 3. What are the 3? First one is P is equal to V into I. This is the general equation from the definition. P is equal to VI. General equation from the definition. Next, P is equal to V square by R. When we can take this? When the resistors are connected in parallel. Next, P is equal to I square R. When we can take this equation? When the resistors are connected in series. Okay, Joule heat energy means here heat energy is ejected from the flow of current. That's why. Now, what is the Joule heat energy? The consumed electrical power. The consumed electrical power in a time is called Joule heat energy. Joule heat energy. Okay. This Joule heat energy is measured in kilowatt hour. Power unit is watt, but more power kilowatt. The time is taken as hours here. Kilowatt hour, kWh. This only utilized in our houses. In our houses we can use the bulbs, fans, grinders, refrigerators, and a television set, etc., etc. Number of electric appliances we can use in our daily life. All electrical appliances, what happen? Works by the electrical power. That utilize electrical power or not? Yes. We can use the bulb, especially in evening hours to night. Means how many hours we can use that one? When we can use that in hours, if you touch a bulb, it is warm up. Warm up means it produces the heat energy. And not only that one, you can see the television set also. If we can use continuously and go and touch to that, it is just warm up. It is just heat it. And next of all, you take a grinder. If you can use a grinder continuously, if we can touch the jar, it produces heat energy. That is called Joule heat energy. Why we can get that heat energy? We are not giving any flame. We are not giving any flame. Even though the heat energy is ejected from electrical power. That's why the consumed electrical power in a time is called Joule heat energy. But the consumed electrical power in a time is measured in kilowatt hour. This kilowatt hour we can use in our daily life as units. Every month in the first week we will get electrical bill sheet. How immediately our parents are asked to us, how many units you are consumed? Our electrical bill is given by the authorities. In the electrical bill, what is that? How many units? These units you are utilized, 40 units, 50 units, 200 units. Unit. 1 unit is equal to how much? 1 unit. Kilowatt hour is also known as unit. 1 unit is equal to 1 kilowatt hour, or 1 kilowatt hour is equal to 1 unit. 1 kilowatt hour is equal to how much? 36 into 10 to the power of 5 joule. This is very important. 1 kilowatt hour is equal to how much? 36 into 10 to the power of 5 joules. Now, here we have two equations. What is that H? Heat energy or Joule heat energy. No need to take H, you take Q also. Why? Heat energy is denoted by Q and also expressed as H. But here I am taken as H, heat energy. Now what is the mathematical expression for the Joule heat energy by consuming electrical power is H is equal to I square RT, otherwise H is equal to V square by RT. Okay, these are the equations. Now these equations we can use while solving that one. Next, what is the use of these equations? What is the use of these equations? What are the equations? The electrical power P is equal to V into I. The electrical power P is equal to V square by R, and electrical power P is equal to I square R. With the help of that only, we will discuss one topic. This is very, 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 very important in our daily life. Okay, in our houses, in your room, we can use electrical bulb. In that room, we can use electrical fan. Sometimes we can use tubes, 1 or 2 in your room. And especially we go to the kitchen room, we have refrigerator, we have the grinder point, tube light, bulb and electrical fan. For all that we have switchboard. What is done? Switchboard. Switches are there. How the switches are arranged on the board? The switches are arranged on the board in parallel but not in series. The switches on the board in our houses, how that are arranged? That are arranged in a parallel but not in series. That are in parallel but not in series. Why? The electrical appliances are connected in parallel in house. This is one of the question. Why the electrical appliances in the houses are connected in parallel? This is very, very important. Now why it is? When the electrical appliances or switches are connected in parallel, but in parallel what is same? In parallel voltage is same. You take a fan, it has resistance or not? Yes. Tube light, it also having resistance or not? Yes. Bulb, it has resistance or not? Yes. Grinder, resistance has exist. Refrigerator, resistance are exist. That all are connected in parallel. Why? Why means in the parallel voltage is same, even the resistor is different. When the voltage is same, the consumption of power is taken by that appliances with sufficiently. When the household appliances are connected in parallel, we have different instruments. Different instruments resistance is different. That's why which resistor are required a sufficient electrical power that is possible when that are connected in parallel. In a parallel what happen? Voltage is same. Voltage is same, even the small resistor or high resistor. When the voltage is same, the sufficient power is received by it, so it doesn't breaks. But one thing is happened. What does that means? That resistance, what happened here, it is less. Resistance is less, what happened? The power is more. Means the consumption of power is more. When the power of consumption is more, when that are connected in parallel, but potential difference is same. That's why the household appliances are always connected in parallel. Why? In the parallel, if the resistance is more, the power of consumption is more. If the resistance is less, the power of consumption is less, but the potential difference should be the same. That's why the household appliances are always connected in parallel. Household appliances are always connected in parallel. Due to the parallel, each and every appliances, if the resistance is different, receive the same potential difference. If the resistance is more, the power of consumption is more. If the resistance is less, power of consumption is less. That's why the electrical appliances doesn't failed, doesn't burns when that are connected in parallel. And one more thing, in the parallel, if any one appliance is failed, it is not affected on another appliances. Means in the house, if the tube light is burns, it is affected on the fan? No. Why? That are connected in which one? Series or parallel? Parallel. That's why the household appliances are always connected in parallel.